So we could also go in reverse. So in reverse, let's say we're given a sum and you want to write it in the sigma notation. How would you do it? So let's say you had the sum cosine of 2 times 3 plus cosine of 3 times 4 plus the cosine of 4 times 5 plus the cosine of 5 times 6. So thinking about writing this in sigma notation, this is kind of a puzzle. It's a pattern, right? Like, where would you even begin?
Does it start at 2?
I think it looks like it's going to start at 2. Yeah. I like that idea a lot. Here's what I'm going to say. Let's do this instead. Let's break this down to a smaller problem. Great. This is, by the way, a fantastic problem-solving technique. But if you want to solve a problem, break it down to smaller, manageable problems and keep breaking it down. That's recursion, which we're going to talk about today. But anyway, so yeah, it looks like it's going to start at 2 and maybe end at 5 or 6 or something. Let's check it out. So the first step to writing in sigma notation, and by the way, sigma, if you haven't seen it before, it's basically like a sideways W or like a really sideways M. You see what I'm saying? First step of writing in sigma notation is to, how did I put it exactly? Is to first look at sequence of summands. So the different parts of a sum are called summands. It's a fun word. And so they form a sequence. So what I'm talking about here is the sequence. If we look at cosine of 2 times 3, comma, cosine of 3 times 4, comma, cosine of 4 times 5, comma, cosine of 5 times 6. Right, just kind of replacing the pluses with commas. Yeah, and that gives us a sequence to look at. Now the next step, I'd say, is to write this sequence in explicit form. So now let's try to write this sequence here in explicit form. So in explicit form, we want to say that AI equals something for all, something like that, right? Where you have some range in the eyes. So what are you guys thinking for AI? I think cosine's a good idea, right? I mean, that's gonna have to be there, I guess. What should we go in the middle?
Is it I times I plus 1?
I love it. I love it so much, Lauren. Yeah, we could do I times I plus 1. And not that I'm trying to get in the mind of Lauren, but I think what Lauren saw is that if you look at here, I mean, they all have cosine, we know that. This is 2 times 3. This is 3 times 4. This is 4 times 5. This is 5 times 6. Your mental track of like your index should be looking and going, hey, I have 2, 3, 4, 5 here. So I'll call that my I, right? I'll run through 2 and 5. And everything else, I just have to relate to that. So how does 3 relate to 2? Well, it's 1. It's like 1 more than it. How does 4 relate to 3? It's 1 more than it. How does 4 relate to 5? It's 1 more than it. 6, 1 more. So if AI equals cosine of I times I plus 1, when I equals 2, right, we're going to get cosine of 2 times 2 plus 1, which is exactly this. When I equals 3, we get cosine of 3 times 3 plus 1, which gets us this. 4 times 4 plus 1 is that. So this totally works. And where should the range be?
2 to 5.
2 to 5. Exactly, right? Thank you, Lauren. The tricky part is you might think 6, but remember, we're considering I to be kind of like this first number here, not the second number. The second number is the I plus 1. Now, you could have also said, if you wanted to, AI is the cosine. You could have looked at going 3, 4, 5, 6, looking at the second number instead. And there, then the first number, how it relates to the second number, is 1 less. So you could have said I minus 1 times I, but this time you're ranging from 3 to 6 instead. Both totally valid. Doesn't matter. Doesn't matter how you think about it. Just, you should be thinking something like this. All right. Then once you have that, I'll say then translate to sum. Because once you have that, it becomes easy. So our sum then is the cosine of 2 times 3 plus the cosine of 3 times 4 plus the cosine of 4 times 5. Look at me saying the cosine. I feel like your uncle, it says the COVID. Plus the cosine of 5 times 6. And that's going to equal, why do old people say the? I don't understand. Yeah. So now if we go back to the sum, I mean, the way you translate from this sequence to this, just you put pluses back in, right? And that totally makes sense. Because that's what we're trying to find. We're trying to find this sum. The way you translate this though to explicit form is really easy. All you have to do, I wrote it up here, but I erased it, I don't know why. Up here was I equals 1 to n of AI. The point is, this explicit form is perfect for translating the sigma notation because it already tells you the range and it already tells you what each term is. This is going to be the sum from I equals 2 to 5 of AI. I mean, that would do it, right? But what that really equals is the sum from I equals 2 to 5 of the cosine of I times I plus 1. So the point is, once you have it in explicit form, real simple. All you gotta do is gonna be the sum of this term, of this explicit form of the term, ranging on the same range. My eye itched. Any questions? Good. Hope this makes sense. This should be a review for a lot of you. So, but just in case, there you go. Or maybe you didn't understand it, but now you understand it. But now you understand it better. Who knows? Never harm in doing math twice.